Viewers, welcome to EF. Today I would like to discuss about the formal definition of deterministic Turing machine or Turing machine and what is the actually machine is doing with the transition relation notation and what is the input configuration or arbitrary configuration. In my previous video I already explained about what is the informal definition of Turing machine or complexity theory, some other definitions. So let's see how the formal definition looks like of Turing machine. Formally, a deterministic Turing machine is a tuple M that contains Q is a finite non-empty set of states. We have gamma is the finite working alphabet. We have sigma which belongs to gamma is the input alphabet, and we have this blank symbol B, which actually means that there was never ever written any input alphabet in that cell, and that is saying by this blank symbol. Most of the case in the Turing machine, the leftmost cell are defined as the blank symbol. Now we have this transition function that is defined with the delta. Transition function maps with the input where we have um, Q non-empty set of states, and we subtract this final state Q yes Q no from this final state, and Q is multiplied with gamma in the input part, and then we get the output Q cross means multiply with gamma, multiply with read write head. As many possible state we will get as output. We have also this initial state Q naught, and we have this final state Q yes and Q no, which belongs to Q, and Q yes means that Qj means QS here, and that means that input is accepted by the Turing machine, and Q no it means that the input is rejected. In deterministic Turing machine, if the input is accepted, then it will say QS. If one input is rejected, then it will say Q no. We have, without loss of generality, Q intersection with gamma is phi. So the next question is about transition relation notation. But before that, I would like to mention that the first symbol is symbolized with the transition relation notation. The second symbol is used for the implies that maps input string to the output string possible symbols. So this second symbol is used for transition function. So let's see, the transition relation of a machine M is defined by this transition relation notation function with M, and then if we apply on uh, gamma star Q many states and then gamma star, then we will get a configuration of input symbol alpha, these many null many states, or you can say in one state with the transition relation movement, we will get beta. So alpha is my input where I have this alpha 1, sigma 1, p and sigma 2 and alpha 2. If my alpha 1 and alpha 2, which belongs to working alphabet, sigma 1 sigma 2 is a single symbol of working alphabet, and PE belongs to a single state of Q. In that case, depending on my transition relation function and the read write head movement, beta will be changed. So if I have a input state, I have a initial state. Uh, I have a state, not the initialist. I have a state Q pointing to Q sigma 2, and if I get the new state is Q and new symbol is Q sigma 3, and if I have a left movement, then I will get the output beta, where alpha 1 Q sigma 1 sigma 3 and alpha 2. Similar fashion, only the changes will be in the depending of the read write head movement. So here in the second case I have no head movement, so it will be at the same position. The state will be only change Q in case of P, other than the Q3 symbol will change. The last one is also right movement, so it will the Q will stay um, after changing the symbol of Q3. Now we have some special cases also, that is if we are using this blank symbol, then we will use this gamma um, plus. So these are the special case. I would not like to explain it now. So let's see, if I have a transition function of a Turing machine, then that depending on the transition relation notation on the set of gamma star Q and gamma star is given by alpha transitions to beta, where alpha and beta are two arbitrary configuration which belongs to gamma star Q and gamma star. Now what is the configuration means? Before that, let's see the visual representation of the example. So see, here I have in the alpha position Q2 is pointing to P, and then if I have a transition with the new state Q with the symbol replaced Q3 and no movement, then the beta will be changed in a position of as follows, where my Q will be changed at the position of P, and I will get a new symbol at the position of alpha 2. The same is also doing for the left head movement. First I will change Q2 with Q3, and then I will change my state with P by Q, and then I will movement the head into left, so now it's pointing to the left side. Same will happen for the right movement also. See, the beta, new beta is alpha 1 Q1 alpha alpha 1 sigma 1 alpha sigma 3 and Q, and then alpha 2 will be the new beta. Now the question is, what is actually configuration means? Configuration means that the symbol or the setup string that is used for the input or output. In this discussion, this alpha and beta are some arbitrary configuration for working alphabet, where the Turing machine it can be written in this case as alpha 1 P and Q alpha 2, where alpha 1 and alpha 2 are belongs to working alphabet for combination of working alphabet, and sigma belongs to single input working alphabet, and Q is a single state. So that's all for this video. Thank you for watching. See you in next